All right, we're recording. So today's note is 3.1, rate of change or slope. So some of you already know this from previous math class. So I know you already have seen some of this stuff from your previous 8th grade class. So just hang with me there. I'm going to start giving some definitions, okay? All right. So the first thing we want to know is, what is a rate of change? So let's write down the definition of rate of change. Okay, let's write the definition of rate of change. What comes to your mind, and this is a question for you guys to answer, what comes to your mind when you see the word rate? Please raise your hand. Colton.
Slope.
Slope, it will be, slope is another word for rate of change, but forget about slope. When you just see the word rate, what comes to your mind? What do you think? A fraction. So rate is another word for ratio, or the same word for fraction. Good job. So a rate of change is another word. Another word is ratio of change, or a fraction is represented as a fraction. But Colton is right. Rate of change, and here in mathematics, we want to be making a connection with slope. All right. So this is a pattern. A pattern in which something is changing. A pattern in which something is changing. So something can either change in a positive way, or it can also change in a negative way. So I'm going to make myself a note. Something can change in a positive way, or it can also change in a negative way. And something can also not change at all. For example, my paycheck. It doesn't change at all. Every month is the same. So some things a rate of change can be 0, not change at all, okay? So that is the definition of a rate of change. Let's be more specific and talk about linear rate of change, okay? So linear functions rate of change. Now I'm going to use the word that Colton is talking about, okay? In linear function, we want to talk about slope. Okay, and the slope is a rate of change, just like Colton said at the beginning. Rate of change reminds me of slope. That is what it is, and that is what we want to keep in mind for this whole section, is slope. So in slope, we have a little formula for it, okay? So let's write the slope formula. Slope formula. Can you guys see okay?
Yeah.
Okay, slope formula. All right. So the slope formula is y2 minus y1 all over x2 minus x1. Okay? And we use the letter m for slope. I don't know why. I used to remember why. I don't know. At this moment, I don't remember why they picked the letter m instead of the letter s. I think it's because the letter s represents something else in mathematics. Squared, maybe, like sides of a square. But they use the letter m. M equals the slope formula. Okay, so that's what we're going to use for every time I want to find the slope. So notice that if I pick y2 and subtract y1, I also have to start with x2 and subtract x1. I cannot switch the order or I'll get a wrong answer. If I do y2 minus y1, and then down here I flip it and I do x1 minus x2, I get a wrong answer. So the 2's has to come first, the 1's has to come second, okay? And that's the order that we're going to have to keep it. We don't always have to use the slope formula if we're doing it visually, a visual check, if we're looking at a graph. So today we're going to do it in 3 ways, okay? We're going to identify the slope in 3 different ways. We're going to identify from a graph. We're also going to identify from a table. And we're also going to identify what is the slope from a set of coordinates. of coordinate pairs. Okay? So from a table is usually the student's favorite way of identifying the slope. So I'm going to start with the table, then I'm going to move on to the graph, and then we can move on to the coordinate pairs. That's when we usually use the slope formula. For this two, usually are very, very visual. So from the graph is very visual, and from the table is also very visual, but you can use the slope formula in any of them. But I prefer to look at visually. Some students are visual, and some of them, like, they want to use the formula for everything. I'm okay with that. All right, so let's go ahead and start with an example from the table. I want to go with from the table first. So if I have this table right here, x comma y, and go ahead and write the same example as me, okay? So if I have 1, 2, 3, and 4 for x values, and we have -2, 1, 4, and 7. Okay, so those are my y values. Here are my x's, here are my y values. Okay, let's see if I can use 2 different colors here. Okay, so remember, the slope, which is m, is a change that's happening on the y values over a change that's happened in the x values. And that's how we look at it when we're looking at visual, just being able to identify it visually. All right, so take a look at the y values. How am I going from a -2 to a 1, and then from a 1 to a 4, and from a 4 to a 7? Nolan, what are we doing there? What's the change?
It is changing
By 3? Are we adding a +3 every time?
Yes.
Okay, so if you add a +3 here, you do get a 1, and a +3, and a +3. So I already know that my slope, my change in y's, is a +3. Okay, and then it says the change in the x values. What is happening on the x values from 1 to a 2, 2 to a 3, and 3 to a 4? What do we think there? Hayden?
You add by 1.
You add by 1 every time. +1, +1, +1. So easily we can tell that the change in the x values is just by 1. So our slope is just m equals 3 over 1. And I'm going to keep it as a fraction. I know we are used to not having to write the number 1 in the denominator is not necessary, but I'm going to keep it. Okay? Have you guys ever heard a little saying of like rise over run?
Yes.
Okay, so that's what it is right here. For the y values, we're going to call it rise. And for the change in x, we're going to call it run. Do you ever wonder why is it called rise and run? Colton?
No, because when you're graphing, you always want to go up before you go to the side.
True. True. Who else? Why do you think is a rise over run? Anybody else? Hayden?
Because the y is on the top and the y-axis is up and down.
Oh, there we go. Because the y-axis is a vertical axis, is an up and down axis. And the run is a horizontal axis. So you run left to right and you rise up and down. Just exactly what you said. So good job. That's why it's called rise and run. The changes in the y's over the change in the x's. So is it easy to tell the slope from a table? It is easy, huh? From a table, it is easy. Let's do one more example. I want you to tell me what is the rise, what is the run, what is the slope from a table, okay? All right, let's do one more table. Here we go. X values and Y values. Let's see what my next example is. Let's see here really quick. There we go. Okay, so I have a 0, 2, 4, and 6. I want you guys to tell me what is the slope really quick. I have a 1, a -2, a -5, and a -8 for the Y values. Some of the students, they see it really, really quick. So I'm going to write it down. M equals change in the Y values over the change in the X values. And I'm going to give you 1 minute there for you to tell me what is the slope. Okay, Ivan, what is the slope?
The slope is
Negative 3 over 2. Colton, is that was going to be your answer?
Yeah.
Awesome. So let's check. From 1 to a negative 2, we are subtracting a 3, right? And then you subtract a 3 again, and then you subtract a 3 again. So the change in the y values is negative 3, and the change in the y value, the x values is adding a
2.
positive 2. Thank you. Okay? So that is that easy. So can you see that from a table it's really easy to tell the slope?
Yeah.
Okay. Now let's move on to the graph. The second thing I told you is we were going to be able to tell the slope from a graph. So right underneath here, I am actually going to use exactly the same order pairs I just gave you there. So it's kind of like unfair, we already know the answer. But from a graph, I am going to look at this. I'm going to actually graph those points right there. 0 for x, 1 for y. There's my first point right there. And then 2, negative 2. 1, 2, negative 1, negative 2. So I'm going to be a little bit, the scale on my worksheet here is not going to be very nice because I don't have a grid. And then 4, 2, 3, 4, negative 5. Negative 1, negative 2, negative 3, negative 4, negative 5. I'm going to stop right there. It's a little bit off. I'm going to draw my line. Okay. So, it's like I said before on the notes, you either rise and run, because you have to get up before you can run. Or when something's on fire, what do they say? Drop and roll. Drop and roll, right? Colton.
You have to get on the elevator before you can go up.
Say it again?
You have to get on the elevator before you can get up.
That's true. That is true. So, is either you get up and then run, or you drop and roll, right? So, in this case over here, if I want to go from point A to point B, I'm going to have to drop 1, 2, 3, drop 3, and then run 1, 2. Okay? So it's why is my pen not working? Okay, so I had to drop 1, 2, 3. I dropped 3, and I ran 1, 2, 2. Okay? So that's why our slope is drop 3, run 2. Exactly what we got from the table. Does that make sense? So you either rise and run, or you drop and run, or drop and roll. So can you see that from the table and from the graph are the easiest ones to identify the slope? And the students have usually no problem with from a table and from a graph. What they have a hard time with is with the from a coordinate pair. I'm pretty sure there's a freeze button here. I found it. Let's see if it works.
Speaking.
All right, try it again, Colton.
Student speaking.
Okay, so let's keep going. Let's try from a set of coordinate pairs. All right, so let's try coordinate pairs. Isn't that nice? The day that I try to record a video, we get phone calls and all kinds of stuff.
Mr. Tanogo.
Oh, yeah, he's not here. Thank you, Colton. All right, so let's do from order pairs, from coordinate pairs. So I have an example here. Example, let's do 2, 0, and let's do negative 4, 3. Let's see what we get. So we did it from a table. It was kind of easy to tell from a table. We did it from a graph, and we can practice more. But let's see from a coordinate pairs. If I am doing from a coordinate pairs, is not very visual. I'm going to use the slope formula. M equals y2 minus y1 all over x2 minus x1. Okay, now you have to label which one you want to be the first set of pairs and the second set of pairs. So I'm going to label this one my x1 and this one my y1. This one I'm going to label my x2 and this one my y2. You have to keep the same order or you get wrong answers. Okay, so y2 will be a 3. minus. Now this minus is part of my formula. It always has to be there. Minus y1 is a 0. And then I do x2, which is a negative 4, minus my x1, which is a 2. Take a second and look at it. What is 3 minus 0? 3, good job. What is negative 4 with negative 2? Negative 6. Okay, whenever we have a negative either on the numerator or on the denominator, we can pull it to the front and say negative 3 over 6. Okay? Now, can we reduce this? Yes, reduce by 3, right? We can divide this by a 3 and divide this by a 3, and we get negative 1 over 2. Thank you. So the answer is negative 1/2. So we always reduce. Now, my student in second period asked me, why did you move the negative to the top, right, to the middle of the fraction? I told him it's kind of like the situation, I get married and my husband already had debt. So when we get married, now we both have that same debt, right? We owe something. So when the number 3 and the negative 6 became a fraction, they share this negative sign, okay? So that's how you do with the coordinate pairs. Let me give you one more, and I want you to practice. Okay, I want you to tell me the answer because I know you guys are super sharp. You can tell me the answer. Okay, another example number 2 for coordinate pairs. How about, I want to do something with lots of negatives. Let's do negative 2 comma negative 1. And let's do negative 2, negative 1. Let's do negative 4 comma, I don't know, let's do negative 3. Let's see what we get there. Label it carefully and then do the formula. Okay, so this is going to be my x1, my y1. This is going to be my x2 and my y2. Okay, so for the sake of time, because we're rolling on the video, I'm going to ask you, does someone have an answer? Okay. Ivan.
Negative 2/3.
Negative 2/3. He's saying that's the answer. My pen is not working. Here we go. Negative 2/3. That's what he's saying the answer is. Colton, is that what you had? What did you have?
Negative 3/7.
Negative 3/7. Does anybody have a different answer? Ray, what do you have? Red.
I got negative 2/3.
Oh, same as up there.
Yes.
What do you have, Shelton? 1/3? That's so different from each other. Let's find out. Let's find out. All right. So y2 is negative 3 minus, remember, the minus is from my formula. I cannot take that away. But then I have a negative 1. I'm going to put it in parentheses so I don't get confused. Okay? And then we have negative 4 minus from my formula, and then I have a negative 2. Let's see what we get. I don't remember who told me these answers, but I'm going to call student A, student B, and student C. All right. So negative 3, when you have a negative times a negative becomes positive. So I have negative 3 plus a 1 all over a negative 4. Negative times a negative becomes positive 2. All right. Let's see what we get here. Negative 3 plus a 1 is a negative 2 all over. Negative 4 plus a 2 is negative 2. Huh. What is negative 2 divided by negative 2? A 1 over a 1, or just a 1. And your answers, none of them are right. Should we try it again? Yeah, be careful with the negatives. That's why I wanted to do it with lots of negatives, okay? I wanted to do it with lots of negatives because that's usually how the students make mistakes. Let's do one more time. I want to do with negatives like that so you can get it right. Okay, let's do example number 3. All right, example number 3. I'm going to throw in some negatives at you guys. Negative 3 comma 0. And let's do 3 comma negative 2. I don't even know if that's going to work, but let's find out what happens. Interesting. Okay, I put the formula on the board, y2 minus y1 and x2 minus x1. So this is going to be my x1, this is going to be my y1s. They're the first ones that are in front, so I'm going to call them the first ones. These are the second ones. There we go. You guys are super fast at this. Hopefully you don't make a lot of mistakes. Colton, what is your answer? Student A.
Negative 3 over 1.
Negative 3 over 1. Student B. Negative 2 over 0. Ugh, that's scary because we got 0 in the denominator. Student C.
Negative 1 over 6.
Negative 1 over 6. Okay. Farah, did I see your hand up there? No, it was Jacqueline. It was Fatima. Fatima, what is your answer? Negative 1 over 6? Okay, same as over here. Okay, so I have 3 students' answers right there. Let's see who's right. Okay, so student A, B, and the C, D friends here got the same answer. All right, so y2 is a negative 2. Minus is from my formula. And y1 is a negative 3. There we go. Okay, I put in parentheses. And then I have x2, which is a 3, minus from my formula. x1, I messed it up, huh? Yeah. Okay, so negative 2 is my y2, minus a 0. All right, this is not right. This is, let me start all over again. Negative 2 minus a 0. All over a 3 minus a negative 3. There we go. Okay, so what is negative 2 minus a 0? What is negative 2 minus a 0? Negative 2, right? What's wrong, Colton?
Isn't it still wrong?
Is it?
It shouldn't be negative 3 over 0.
No, it's y2, negative 2 minus a 0, and 3 minus a negative 3. Okay? So negative 2 minus a 0 is negative 2. And negative times negative over here makes a positive. So it's 3 plus a 3. Which simplifies to negative 2 over a 6. And then when we reduce it by 2 on top and bottom, what do we get? Negative 1 over 6. There's 2 students over here. I don't remember who it was. Ah! Negative 1 over 3. So no, 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 and no.
Wait.
What do you think, Yvette? You reduced the top, but you didn't reduce the bottom. Just like my mistake was.
Oh yeah.
Huh?
Flip mine.
You flipped yours. See, even I make mistakes if when I try to go too fast. Okay? All right, this problem over here was 3. So guys, what I want to point out to you is that these negative things are going to cause a little bit of headache. So be careful about it, okay? So we did it from graphs, we did it from tables, and we did it from coordinate pairs. I just want to, on your worksheet, I am going to do, I just have to mention one more thing. And I want you to write on your notes. There are 4 types of slopes. There are 4 types of slopes. Okay? And I like to do that showing you a visual. Slope is like, have you guys ever hiked any hills or mountains or something? Have you ever gone on a hike? So there's either a positive upslope or sometimes there's a negative. Every time you go up, you have to come down. Here's my favorite visual to show these 4 types of slope. You go up the hill, you have to come down the hill. Sometimes you have flat walking periods of time. So if I'm going up the hill, I'm going to have a positive slope. Those are for linears that go up, okay? Positive linears. Sometimes you get a positive slope. And then if you're coming down the hill, if I have a negative linear, if I have a line that's going down, we're going to have a negative slope. Okay? So we have positive slopes. We have negative slopes. And then when you're walking, if you are walking on a horizontal plane, this is a constant. Do you have any steepness there? No. There's a positive steepness going up here. There's a negative steepness coming down. But there is zero steepness here. Zero slope. So we also have the zero slope. Okay, so that's 3 of them. You can have a positive, you can have a negative, and you can have zero slope when you have a constant, like Colton is saying. If you have a constant line, you have a zero slope. Now, how about if I have this right here? How about if I have a vertical? Is there a slope there at all? No. Who can climb up walls?
Spider-Man.
Spider-Man. So this is undefined because he is not real. You all said Spider-Man at unison. Yes, undefined. There is no slope when we have a vertical line. Okay? I'm sorry, I shouldn't say that there's no slope. It is undefined. The zero slope is when you have a constant. Okay? So those are the 4 kinds of slopes. It is either positive, negative. Zero slopes are for constants. And then you have the undefined. Undefined. Okay? And we'll explore more of these during the worksheet that we're going to be doing. All right? So we did it from tables. We identify slope from tables, from graphs, from coordinate pairs. And I like you to keep in mind that there's always positive linears, negative linears, zero slope when we have a constant line, and any vertical line like this is undefined slope. All right? So thank you so much, guys. I appreciate you helping me record this.